My dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 561. In this lecture, we will try to understand weight initialization. So, one of the very important aspect of training deep neural networks or deep multi-layer perceptron is how do you initialize the weights of neural network. So, if you remember, we mentioned that the weights in SGD or in the case of deep learning, when you are doing back propagation, we said we initialize the weights randomly. Actually, we pick these weights Wk, Ij from normal distribution with zero means and small variance. Let's understand why do we have to pick the weights from some distribution. Let's take idea 1. What is my first idea? What happens if I initialize all of my Wkij is to 0? That is Wkij equal 0 for every I comma j comma k. This is very bad idea, by the way. Let me explain why. The first reason here is because your weights are the same. Remember, your weights are the same. Imagine your activation functions Fij's are also same. Let's assume your activation functions are all ReLUs. Because your weights are the same, all your neurons compute the same thing, isn't it? Because your weights are 0, what happens for any given neuron? What is the input? Your input is x. X is the input that is coming here. Coming here means coming into the neuron, and there are bunch of weights. What are the weights? W is my weight, Z which is input to the function. Neurons means you have activation function here. What is the input to this particular neuron? Here Z is input. Means that's what we used to say f of Z. What is my Z? Z is W transpose X. What is X? X is input, W is weight vector. Isn't it? We are assuming if W itself is 0, that's the problem here. You are initializing weights with 0. If W itself is 0, then what is my Z? Z becomes 0, W transpose X. If W itself is 0, W transpose X will be 0. What is my Z? Z is W transpose X. It will be 0. You are always sending an input of 0. Why? Because Z equal 0 means we used to say f of Z, isn't it? Your Z becomes 0 means it is f of 0. F, what is my f here? Activation function. Every neuron in your whole network, when you input 0 to a neuron, every neuron outputs the same thing, which means there is no learning happening, and they have same gradient, updates happen to all the neurons. This is true even if you give all the weights the same value, whether it is 1 or 0 or any number. You are suffering from these two problems. What is the first problem? All neurons compute the same thing. My second problem is same gradient updates. This is called issue of symmetry that we don't want to have in weight initialization. If you initialize all your weights to the same number, I will repeat, if you initialize all your weights to the same number, it could be either 0 or 1. What happens? All the neurons are computing same thing. You are getting the same gradient updates. All your weights are getting updating the same way, which means your model is not learning anything much. It will end up behaving like simple logistic regression. Isn't it? It might turn out, be fully useless, isn't it? It might turn out to be but what we need, we want our models to be asymmetric. Asymmetric is opposite of symmetry. Why do we want to have asymmetry? Because look at it. Let's assume you have a network where X as input here. Let's say you have layer 1, layer 2, and you have, let's assume you have output layer. You have Y cap here, isn't it? Now, what happens here? If you observe carefully, I have input layer. This one same. I have this is X is your input. X your in where is X? X is input. Yes. Now what's happening here is each of your neurons are learning something. I have neurons here. What are the neurons here? Each of the neurons in the sense this neuron. Here also you may have some neurons. Each of these neurons are learning something about this input variables, and the functions are learning something about the output. For example, here I have these functions. They are learning something about the output of these neurons. Why? Because output of these neurons is input to neurons in layer 2. Means layer 2 neurons are learning something from the output of layer 1 neurons. Isn't it? Yes. Now, if you have asymmetry, different neurons will learn different aspects of your data. Different neurons will learn different aspects of your data. If you have asymmetry, different models are learning different things. Because different models are learning different things, we get an advantage of training, isn't it? If they are learning different things, that will be the advantage, isn't it? You can think of each neuron. As a model. If you have any function in neuron, means for example if you have sigmoids here, I am assuming in each neuron I have sigmoids here in each neuron. Sigmoid is actually is a logistic regression model. Each of these activation functions are actually logistic regression models. If you have sigmoid I can say each of these functions in neurons are actually logistic regression models if you have sigmoid activation unit. If you remember our arguments from random forest GBDT that we discussed in ensemble models, the ensemble models are very, very important idea that we learn. Was the more different the base models, are, the better output of ensembling, either through bagging or boosting, doesn't matter. The important aspect here is the more different the models are, the better will be the output, because each model is learning some different aspects of your input, isn't it? So you can think of each of these neuron as a base model in ensemble perspective. You can think of this as stacking. Literally, what is stacking? Stacking is you have base models, and you learn a model on top of the base models. You can think of this is a very, very simplified neural network, isn't it? And of course we are not doing back propagation, all of that in stacking. Neural network is much more advanced concept than stacking, because you are learning a lot of base learners, and you are co-training them, isn't it? So if you have the same weights, then you run the problem of symmetry which means already models are learned something same already models are learned same thing. Suppose you have 20 activation units, 20 active, let us assume you have 20 activation units across the layers. You are losing the power of training these 20 base models. So asymmetry is something that's super duper important. So you should never initialize all the weights to the same value. Just go through this lecture. I will continue my discussion on weight initialization in my next lecture also, that is in lecture number 562. Thank you very much.